Hi, could you please introduce yourself to the viewers of the Tango Says blog?
My name's Andy Wilson. I'm responsible for the international dimensions of our unmanned vehicle business within BAE Systems. Two aircraft we have here is the Herti aircraft, which has an endurance of about 20 hours and it's a high quality surveillance and reconnaissance aeroplane. And then behind us we have the bigger brother. This is the Mantis, twin engined, fully autonomous aircraft which will carry out surveillance and reconnaissance. It is fully autonomous. There is no man in the loop with a throttle. All you do is launch the aircraft with a click of a mouse. So you plan your mission, you work out where you want to gather your information from, and then you click the mouse and the aircraft goes and takes images. What it does is, with these two sensors in the side, it will take pictures of the area you are flying over. When it finds something that you're interested in, it might be a suspicious vehicle, 4x4 by the side of the road, what it will then do is turn around the turret to give you a very high quality image of that target. That will then be data linked directly back down to your ground station so the operator can see the intelligence instantly. And the whole of that system is controlled by just two guys. You have one guy who is checking on the aircraft to make sure it is going in the right area and it's doing the job you want it to do. And you have the second guy who is your intelligence officer who's looking through the intelligence that the aircraft's gathering. So very simple to operate. All the systems are Windows based, so they're very straightforward to use, and it means that you do not need loads and loads of people to run the system. It can be done very simply with just two guys.
So very straightforward, turnkey solution applicable.
Absolutely.
Yeah.
And all the systems are standard Windows, click boxes.
Yeah, interface is familiar. Yeah.
Correct. Yes, it's a big aircraft, very much the Herti's big brother. Again, using the same technology, it's fully autonomous, but it has two engines. We put two engines on there mainly for safety. We know that the system will probably be flying over the top of cities and populated areas, and so the whole aircraft is capable of flying on just one engine. So if you have an engine problem, it can still fly safely and you will be okay.
So its size, its size and two engines are, you choose that configuration primarily because of safety?
That's correct. Yes.
Okay.
Yeah.
And the payload and sensors?
What we have on the aircraft you can see behind you is we have a multifunction turret at the front of the aircraft which has video for capability for day and for night, infrared, as well as digital stills. This is made by a company in Canada called L3 Westcam. And then in the rear section between the wheels, there is another turret. That is the same imagery turrets that we have on the Herti aircraft here. That's made by a company called Polytech, and that gives you high quality digital images. That gives you the ability to do automatic target detection. One of the key technological strengths of being a fully autonomous system is you can fly up your border on Monday and you can take the aircraft on Tuesday and fly exactly the same route. Because it's a machine, it goes exactly down the same route. But also, it takes pictures in exactly the same position. So when you have that accuracy, the system, the ground station, will overlay the two images. And what it can then automatically do is tell you if anything has changed. So it might be if you fly up an oil pipeline, one day you can see that it is okay, and the next day the system will say there is a leak or there's a problem because there was something there that was not there yesterday.
So it has some pretty useful peacetime uses, yeah?
That's right, and also for disaster assessments. When you're in an area where maybe there has been a natural disaster, an earthquake, you can send one of these into the area to image everything so you can see where you want to put your emergency services without putting a man in danger. There's no pilot that's going to have any problem, but you can find out instantly where you should be sending your emergency services. So it helps a lot of civil applications as well.
Great. To conclude, can you tell us ballpark prices of these systems, or it's very dependent?
It's really dependent upon. This is where it's quite different to normal aircraft, because it would depend on what your role was. For example, if you wanted to look up and down your border, you wanted to do it 24 hours a day, 7 days a week, you would do it with 3 aircraft and 1 ground station. 1 to fly, 1 to rotate, and then 1 on maintenance. So if you have a big border, you would want more and less. Also, it depends on what you want to put on the aircraft. You might want, for instance, some more sophisticated sensors. And really it's the sensors that tend to put the price, make the systems more expensive.
Okay, Mr. Wilson, you're so kind. Thank you for this short interview.
It's a pleasure. Pleasure.
Well, this is the ground station we use to control both the Herti and the Mantis platform. It's exactly the same ground station for both platforms. The only difference is that for Mantis we have a slightly different interface, looking at things like twin engines and different systems on board Mantis. There are 3 key areas. This area here is the mission planning element. This area here is the flight vehicle control. And this area here is where the imagery from the platform is collected and analysed and then eventually sent out to those who ask for it. The thing you'll notice about the ground station is that there are no flight vehicle instruments. There's no joystick, there's no throttle. The system is fully autonomous. What that means is that we can plan a mission which will have the aircraft start at the end of a runway. It will take off, it will climb to altitude, it will then enter the area that we want it to take pictures and take imagery of. Once it's done that, it can come out and do other tasking. It can do a search along a road or a search along a specific feature, and then it can return to base, all without having anybody pilot it. It means that the station that we would normally have a pilot flying the aircraft, the guy that sat here is now more of an observer. What he then does is he monitors the health of the platform, he can see where it's flying, and he can get a status check on the aircraft through an interface that flashes up any particular warning. So for example, all the system in this representation is green. We have a couple of reds and an amber which would perhaps require a bit of checking, but nothing too serious.
Yeah, so very interesting. I can see here pre-programmed waypoints, and Mr. Wilson told me that it is Windows based, so its interface is quite familiar to an average but trained user for this. Yeah,
that's correct. Everything that we have here has been designed to take products that are in existence today and fuse them together to make a very capable system which can be adapted. So if a particular customer has a particular set of requirements and wants to use his own mission planning system, or he wants to use his own imagery system, we can take those capabilities and integrate them into this ground station.
So sensor payloads are fully customizable. So
the sensor payloads will be determined by the customer for the aircraft side of things. We will work with them to determine the best method of taking the imagery that those sensors, or the best data formats from those imagery from those collections, and exploit them on the ground station accordingly.